Hey guys, it's Miss Johnson and I'm here to bring you our notes video on solving quadratics by completing the square. So yes, we are learning yet another way to solve quadratics. There's lots of different methods that we can use to solve quadratic equations, and this is just another one of them. So far, we have learned how to solve quadratics using graphing, where we would look at a graph, we found the values of x, finding the x-intercepts, we would look along the x-axis, okay? Because that's what would make the y value 0. And remember, that's what we're actually doing when we solve quadratics. When we solve quadratics, we're trying to figure out the value of x that makes the whole equation 0. So that was our graphing method. Then we talked about solving using factoring. So we would factor the equation, and if we had something like x squared plus 3x plus 2 equals 0, we'd factor it into x plus 2x plus 1, set each one to 0, and solve that way. So solving by graphing, solving by factoring. We also talked about the square root property. The square root property was one that we looked at. So if we take a look at number 1 on your notes sheet, this is just how we would solve this using the square root property. I would then add 25 to both sides here, and I'd end up with x squared equals 25, and then I need to take the square root of both sides. And remember that when we start with the x squared factor, we end up with two solutions, so it's plus or minus 5. Two solutions there, okay? So that was one. Let's try it with number 2. In number 2, we have a trinomial. X squared plus 10x plus 25. This is actually a perfect square trinomial. If we factored this and looked for a product of 25 and a sum of 10, our two numbers would be 5 and 5. This is the same thing as saying x plus 5 times x plus 5 equals 49, which is also x plus 5 quantity squared equaling 49. Well, take the square root of both sides and get rid of that power of 2. That gives us, we would get rid of that and that. That would give us x plus 5. Oh, that grade doesn't work out very well. X plus 5 equaling plus or minus 7. So then when we split that into two equations, x plus 5 equals 7, and x plus 5 equals negative 7. Solve them both. I get x equals 2, and I get x equals negative 12. Oops, not 10, 12. What? 5 minus 5, x equals negative 12. So I'd have either of those solutions, okay? Let's try it again. Here we have another perfect square trinomial. You've got a perfect square first term, perfect square negative set last term, and a negative middle term, which means you are looking at x minus 8 quantity squared equaling 49. So we would have the square root of both sides. That's x minus 8 equals plus or minus 7. And again, split it into two things. X minus 8 equals 7, and x minus 8 equals negative 7. Add 8 this time, and we get x equals 15. Add 8, and x equals 1. So I have x equals 15 or x equals 1 for my two solutions. So that was using the square root property. Now completing the square is going to be kind of similar to that. Let's just try it one more time. If we had something like x squared minus 6x plus 9 is equal to 32. Now, what's different here is that now we're still looking at x minus 3 quantity squared. This is still a perfect square, negative middle term. So that's where I get the square root, which is x square root, which is 3, subtract in the middle. But now 32 is no longer a perfect square. So when I take the square root of both sides, I'm left with x minus 3, but I'm also over here needing to simplify that perfect square. It's plus or minus the square root of 32. Well, 32 can be split into 16 and 2. So I would have x minus 3 equals plus or minus the square root of 16 times 2. And then that 16 can come out front. This is just what we've been talking about over the last 2 days with simplifying the radicals. So that's plus or minus 4 root 2. This is still two solutions. Split it apart. I get x minus 3 is equal to 4 root 2, and I get x minus 3 is equal to negative 4 root 2. If I add 3 to both sides, I get x equals 3 plus 4 root 2, or over here, I get x equals 3 minus 4 root 2. So two possible solutions. This time they just have a simplified radical in them. So now here's the thing about completing the square. We want to consider having the quantity x plus 7 quantity squared. So if we have something like x plus 7 quantity squared, this is the same thing as if we FOIL it out, we have x plus 7 times x plus 7. And doing all of that multiplication gives us x squared plus 7x plus another 7x plus 49, which is then x squared plus 14x plus 49. So if you take a look at the relationship between these values, this is a perfect square trinomial. And what makes this really nice is that we can easily take this perfect square trinomial, give it our two binomials squared, or the one binomial squared, and then solve what's left. So if we look at the relationship between the numbers in here, your C term was half of the B term squared. You ended up with two 7x's, which combined gave you 14x, while that 7 squared gave you the 49. So that's what we use when we complete the square. Here's the steps for completing the square. There's going to be 5 of them. So the first one, we want to move c to the other side. We need to get rid of the constant that's originally in the equation. Okay, so put c on the other side. Then we need to take b, divide it by 2, and square that. So that's where we get that 14. We divide that, cut that in half, giving us 7, and square it, giving us 49. And that is going to complete our perfect square. That's what we add to both sides of the equation. So you add that to both sides of the equation, and then you factor what you have, take the square root of both sides, and solve for x. So why don't you go ahead and pause the video and make sure you get those steps written down. There's 6 of them there. Okay, so we're going to give it a try with this one that we see here as an example. X squared plus 8x minus 20 is equal to 0. So going through those steps, the first thing that I need to do is get rid of the c that's already there. I want that 20 to go away. So I'm going to move 20 to the other side. So I have x squared plus 8x equals 20. Now, I need to figure out what the c is that I need to add on. So I'm going to add c, which is going to be 8 over 2 quantity squared. That's the b term, this 8 from the middle term, divided by 2, cut in half, quantity squared. That's 4 squared, which is 16. So that's what I'm going to then add to both sides. I have to keep the equation balanced just like always. So I end up with x squared plus 8x plus 16 equals 36. Now I can easily factor this. This is a perfect square trinomial. I cut the middle term in half. I take the square root of 16, they should be 4, so I have x plus 4 quantity squared. Half of b and the square root of 16, square root of c, should be the same thing. Since this middle term was positive, that's why I have a plus 4 there. So that's my factored form. Now take the square root of both sides. When I take the square root of both sides, I get the square root to cancel the power of 2. That ends up with x plus 4 equals plus or minus 6. And there are my two equations. X plus 4 equals 6, and x plus 4 equals negative 6. Solve them both. X equals 2, x equals negative 10. So two solutions there, done by completing the square. So completing the square was me filling in this positive 16 that makes a perfect square trinomial. That's what I'm trying to get there, okay? We're going to go ahead and stop our video at this point, and we'll finish up the rest of our notes tomorrow. Thanks for listening and have a great night. Don't forget to hop back to Schoology and take that quiz.